Hello, how's it going? In today's video, we're going to have a look at lighting. We're going to have a look at three basic types of light: a directional light, a point light, and a spotlight. We're going to have a look at how to organize things so we can send in arbitrary numbers of lights, and why that's a bad idea. But yeah, to start with, I guess I just want to do a brief code review. So I would always strongly recommend that you have a look at the starting point for the project, because this isn't, every single refactor that I do, I'm not going to step through it. So it's in between videos, I will be slightly refactoring the code sometimes. It's just something to bear in mind. So all I really did between this and the last video was oh, by the way, I'll just flash up the final scene diagram of what we want. So I sort of modified my code so that instead of having like camera objects, cube objects and everything, it's all entities. So I'm sort of faking an entity component system without any of the optimizations. But that's fine. I mean, my purpose is to show a large variety of different approaches and then just pick and choose, you know, add your own experience into the mix and go with what works for you. So we have a player and a cube, and what we're doing is, yeah, we've still got the spin player function. That's still there. In the update stage, the entity, if it is a transformable entity, then it computes its model transformation matrix. If it's a camera entity, then it computes its view matrix. And yeah, so then that data is read by the renderer. So just a sort of a bit of an overview of how this works. This is model view control. The model is like the underlying database for the environment, which is read by a renderer. And the renderer has the job of reading that data and outputting it. So now this gets quite a bit simplified. We can simply read the view matrix of the player. We can read the model matrix of each of the cube objects, and it's the job of the scene manager to make sure that those have the appropriate components so those things can be readable. And again, also the way we can, so typically we can just declare all our variables like that, but give it a second. There we go. Oh no. Well, anyway, Metal should be complaining. Xcode should be complaining because this variable has not been initialized in the constructor. So the way we get around that, one way, is to make these all optional, and then that's fine. We don't have to explicitly set them. We can simply set them later. That is a bit annoying because we have to keep unwrapping the optional objects, variables, but another approach is we could simply put in dummy data and initialize it with like placeholder data. That would work as well. So now that we have that, we've had a brief look at the code, let's set up the scene so that we can light it. At the moment, if we run this, we should see just a block. Just a cube. We want to put a plane underneath the cube. So in order to do that, we need to have, I'm going to make a mesh and a material. By the way, I'm putting my, where is it? I'm putting my meshes, materials inside the assets catalog. Makes them a little easier to load. So you can see I have the arty texture from before, and I've put in a wood.jpg, you know, just a basic texture there. And this assets catalog handles everything that needs to be handled, basically. So what I can do is I can go to my, oh yeah, I also need the model. So here I have this cube, object, and material. Just open this up. And I do have this, I did make this before. Oh, not model, but models. Yeah, I have this ground, so we can grab these. Put them in, yep, great. And then I can go to the renderer and grab those, make those assets. So we have mesh, I'm going to change that to cube mesh. Okay, and as you can see, I've already created my 2 different materials. Okay, so then I can go down here and just grab that. And then just go through all of these. So because both of these really are using the same layout, it's an okay approach to simply take any of the models, any of the meshes, it doesn't matter which one, grab its vertex descriptor and set that for the pipeline. Okay, so it's a great idea just to rerun it and check that it's working. Even if it does what we expect, it's a good piece of advice to never be never be too far from a working program, if you know what I mean. You don't want to do too much digging around in the weeds. Okay, so now let's go to our scene, and we're going to make a, what is it? Let's make a set of ground tiles. Okay, so what are we doing here? Let's go ground tiles is an empty list. So we're going to make an entity, and we're going to specify that it's something which is transformable. Okay, the position will just be the origin. And for the Oilers, yeah, let's just set it as blank for now and see when we render this, we might need to readjust it. Okay, now we might get a funny error here. Let's give it a second. Yeah, so it says here, self ground tiles is being used before being initialized. This is a little strange because why is it complaining that we're accessing ground tiles here when we access cubes? I'm not 100% sure. Let me know what you think. My guess is that when it appends something, it sort of shuffles everything that is past that point in memory. So if you imagine a class as like a box of boxes, if we make box 2 bigger, we need to move box 3 to account for that. And now it's saying, hey, but I don't know what's in box 3, so how can I resize box 2? So the solution, I would say, is declare that all the boxes are empty at the start, and then do the resize, so to speak. So we have all the fixed memory allocations up here, and then this should be fine. Little strange, little esoteric. Okay, so what do we want to do here? Well, we want to update the cubes. We also want to update the ground. I mean, it's a very boring update, but the reason I'm going to keep this here, refreshing every frame, is that in principle, we might want to change things later. So it's a good idea just to have it. Unless we do something really crazy. But anyway. Okay, so I'm pretty happy with that. We'll now go to the renderer and we will render the ground. So what are we doing here? We get the cube mesh bind that in. So that's the cube model's ready to go. The arty texture is ready to go. And then we look through and render all the cubes. Okay, let's grab this. And at a future point, I mean, we could put this out into its own function. There are some performance risks there, but it's okay. Okay, go ground mesh. So we'll bind that in. We'll send in the wood material. Then we want to loop through the tiles. And we want to draw the meshes of the ground mesh. Okay. Sounds pretty good. Okay, let's go ahead and run that, see what we get. Well, it's there. It's a plane. The rotation's a bit off. That's okay. Let's just go back to the file and adjust the rotation until it looks right. So this, I say this so many times, this should be an exact science. It's not. And the reason it's not an exact science is that I honestly don't pay a lot of attention when I export Blender files. So let me just do the obvious thing. It looks like it's going around the y-axis, so we'll rotate it around the y-axis. That does absolutely nothing. Okay. Let's change that, whoops, let's change that rotation to the z-axis. It does something, but it does the wrong thing. So let's change that rotation to the x-axis. And now we have it. That's looking great. Okay, let's set this up. Let's make a light. Start with the directional light. So this is a point at which I'd say, well, we might want to reconsider the approach that we're taking here. Maybe make a light class and have different things, but here's how I'm going to do it. So the light is going to be an entity, so we'll add a light component. It's a Boolean value, and we're going to have a color for the light. That'll be optional because we're not necessarily setting it right now. And I'm just going to go to definitions, the bridging header, and I'm going to add a light type. Just why not? I'm going to have directional lights, spotlights, and point lights. I'm just future-proofing, just in case I want to check this in future. What am I doing? It's an enum, not a struct. Okay, good. So we have that set up, and I'm going to add that attribute over here. So I'm going to say, okay. Okay, now in our initialization, we'll go self. Set that to false, okay, and then similarly, we'll go down here and we'll go okay. Cool. So add light component. What we'll do is we will set a few things. Yes, we want, for directional light, we want the color. We also want the Oilers. Okay, so just indicate that. Say we've got a directional light. Okay, great. And then we'll go down to the update. And at the update stage, we're going to set the forwards vector. The forwards vector will be used by the shader. Okay, and this is another point at which you would say, well, maybe this entity component system isn't a great approach because we are potentially adding overhead to other objects, update functions, and yada, yada, yada. It is what it is. This is just one way to do it, one way of many. Okay, and side note, it is beneficial to see bad ways of doing things because it sort of spurs you to come up with better ways. That's my perspective, at least. Okay, so, right, we're setting that up. Now we want to create one of these. Okay, so we have the sun object, and just the same way that we had to, set the fixed size things before anything else, we will set this as well. So we'll go add directional light component. Now the Oilers, I'm going to go with, again, adjust this as you like, but I'm going to go with 0 around the X, 135 around the Y, 45 around the Z. And the color, I'm going to make it yellow, so that'll be and what I'm going to do is I'm going to update the sun once and then never again. Okay, cool. So that is set up. Now let's go back to our bridging header and just add a description of the directional light so that our shader can understand it. We can now go to our shader and set up the fragment shader so that it's taking in light. Let's get rid of this right now. Okay, so what are we doing? We're taking the output from the vertex shader. We're taking sampler and everything. Okay, that's great. Let's also take a light. So I'm going to pass it in. I'm going to pass it in through the buffer. So like set vertex bytes at index 0, and then we've got it. Okay. I'm just going to refactor this a little bit. So we're going to make I'll call it a base color. That will be all of this. Okay, then I'm going to do some ambient lighting. So we'll go, maybe I like 0.2 consistently. I use it in all my tutorials. 0.2 is a good multiplier for ambient. What we want to do is we want to return. Okay, let's run that. Good, we've got ambient lighting there. Okay, let's add diffuse lighting, and for this we're actually going to use the sun. But we don't have a normal, so let's just go with a sort of test normal. So we'll go, let's just say everything's up. So we have 0, 0, 1, and normal's pointing straight up. And then we're going to get calculate the amount of light we're getting. It is the dot product of the normal and the well, okay, so if the forwards direction of the light is straight down, we want to measure the rebound of that. So we'll just take a subtraction, reverse the direction. This could potentially be introducing a negative number, so we'll go max of that with 0. And then we'll use this, so we'll say color is increased by light amount times, where are we? The texture times the color of the sun. Okay, we're going to have a problem because we need to send the data from the game scene into the shader. So we'll go to the renderer. Where are you? There we go. Okay. And maybe just after the camera data. Okay. In fact, copy it. Okay, so let's go. Actually, I just call this sun. Okay, so we create a directional light structure, and then we're going to set its forwards as there we go, and that should be all right. So we're going to set fragment bytes. We're going to pass in the sun, the length. We'll get the stride of that. Oh yeah, of course we need to unwrap those optional variables. And index is going to be 0 because this is buffer 0 of the fragment shader. There we go. Let's give that a shot. And yeah, shockingly, it works. Of course, it doesn't look accurate because we're not using the model's normal data. We're just passing in a single constant vector for everything. So I could change that constant vector and the lighting would change for everything. So if I go, I don't know, let's change this to some random. Okay, the lighting changed. Great. What does that mean? So, yeah, we're going to need to get the normal data from the actual model. Okay, let's go to our object mesh and change the attributes so that we're also storing the normal. We can just simply grab this section, paste it. This is going to be the normal data. That is attribute number 2. It's a, yeah, 3-dimensional vector. Offset is being set automatically, so that is fine. Buffer index is 0. Yes, this is all operating on buffer 0. And want to increment by the size of a vector 3. Okay, this is all fine. We just need to go down here and set the attribute name or the attribute pointer and say, okay, that is attribute 2, and it's going to be a model vertex attribute normal. Okay, so that data's coming in. That data's coming in just fine, but we need to set the shader up so it's consuming it appropriately. So we'll go to our shader, and here we're going to set this up. Okay, and I'm just gonna go ahead and set a bunch of these. So we want to output information from the vertex shader to the fragment shader so that we can render properly. In order to do a full sort of Blindfold lighting, we'll need to pass through the normal and the camera's position to calculate reflections accurately. And we're also going to pass through the fragment position. Now, wait a second, you say, aren't we sort of don't we have a position variable here? Well, yeah, I mean, we do. We do, but that it's not going to be set properly because this position is being set in screen space because we hit it with the model transform, the view, and then the projection. It's being set in screen space, whereas I'm going to do my lighting in model space, in world space. So we're not going to do that. Okay, so now what I'm going to do is I'm just going to set this. There's a bit of a trick. So what I want to do is I want to rotate the normal of the model appropriately. In other words, I'm going to need to hit it with a model transform, but my model transform I have at the moment is a 4x4 matrix, which means it includes rotation, scaling, and translation. But I don't want to translate a direction vector. That doesn't make sense. So I'm going to cast this to a 3x3 matrix. It's a sort of hack to just get the rotation and scaling. But the problem is that for whatever reason, Metal Shader language doesn't have a simple cast. I mean, let's try this. Let's go. Let's try that. And it doesn't have a conversion. Why? It doesn't make sense. I mean, let me know if I'm doing something wrong, but I tried a bunch of things and it didn't work. So what I'm going to do here is called a pro gamer move. And there we have it. That's how you do it. That's how you do it. Okay. Right. So let's set the stuff. So we've got texture coordinate. What's the next one? Normal. Get our diminished model. Okay. And I just realized I'm going to need to set more data. So if I go back to my definitions and look at my camera, I'm also going to need to send in the position. And that's no problem. I can go to my renderer and I can say, alrighty, where are we? Just send that in. That's fine. Where was I? Oh, no, yeah, don't do that. Jeez. Okay. Position. Oh, no, not position. Jeez. There we go, fragment position. So I want to go just model times position, but I need to cast that down to there. And look, rant number 2, this doesn't make sense. Why do we have a cast from a float 4 to a float 3, but we don't have a cast from a matrix 4 to a matrix 3? I don't get it. Anyway, okay, so we're passing that data in, and now let's use it. So now for the normal, I'm not going to worry about that. Let's get rid of that. I am going to need what's called the half vector, though, to do my... Oh, let's just do diffuse first, where we don't need the half vector. Okay, so we've got the diffuse lighting there. Let's give that a shot. Oh, yeah, I probably missed something. What did I miss? Yeah. What's going on here? Okay, just unwrap that. Okay, that's good. That's good. That's what I expect. Awesome. Okay, now let's set some other things. We'll do the specular. Okay, so I'm going to do Blindfold Lighting, and the way I'm going to do that is I'm going to have a bunch of directions. I'm going to have direction vector from the fragment to the camera, and I'm going to go then we're going to get my half vector. And the way that'll work is I will add the two directions. So the first direction I'm adding is the direction to the sun, so that's the reverse of the sun's forwards vector. And the second vector I'm going to add is the direction from the fragment to the camera. Okay, and then I can use that. So set the lighting amount by taking the dot product of the, not the normal, but, oh, actually, yeah, with the normal, but the direction that the light is going to rebound will be the half vector. And then to make that, oh yeah, to make that shiny, I'm going to raise that to a power. And then maybe for now I'll get rid of the sun color just to see if we can make that more obvious, and then I'll add that back in later. Run that right now, see what happens. Well, it doesn't break. Okay, that probably means it's working. Okay, cool. So there we have it. We've got a directional light working. Okay, so let's just refactor this a little bit. I think the entity thing, I changed my mind. Let's get rid of the light entity. Just pop that out. We'll just get rid of that, and then we'll make our own class. So I'll just go down to definitions, and I'm going to add another bit here. I'm going to make an undefined value for my enum, and I'm going to make a new file. So go to model, new file, and then we'll make a light.swift, and this will hold a general class, which it's kind of like a light entity. It could be any of those three light types: directional, spot, or point. So there's going to be a little bit of typing here. I'll just dig in and get into it. Okay, so I've got a bunch of other variables here, not all of them. I'm basically sort of doing some automated light movement and things. Now, I need to look through these and say which of these will be shared by all light types. Will all light types have a position? Well, no, because a directional light type will not. Will all light types have Eulers? No, because a point light isn't facing a particular direction. Similarly, for forwards, now all lights will have a color. Not all of them will have a T parameter because not all of them will be animated. Rotation center, if a point light is spinning, it'll sort of orbit around a point with a given radius, and it might be elevated by a given angle or something. So we're not going to... Yeah, those will only be for the point lights. Okay, so we've got that. Then we'll make the initializer. Okay, fair enough. So we just set the color, and then I'm going to make a series of functions to declare the type of the light. Okay, no worries. This is the same function we saw before. Then I'm going to just keep going, do the whole thing. So then we'll have the spotlight. Okay, so here if we have a spotlight, then it has a given position and some Eulers, and I'm going to be sort of modifying that position with respect to time, so it'll have a parameter for animation as well. Okay, so when we make a point light, that point light is going to sort of be spinning around on an invisible circle, going around some point. And what we're going to do is we're going to add a t parameter to animate that, and I'm also going to declare a position because, well, we're going to need a position. I'm going to set that to why not? Doesn't matter, we'll be overriding this anyway in the update function. Okay, so those are the declaration functions. I know this is a lot of sort of stuff. Now let's get to the update. So for the update, we're going to have 3 possible branches depending on the type of the light, and these are mutually exclusive, so only one of those branches will be taken. Okay, so there's our update for the directional light, and just as a sanity check, remember, we never want to be too far from an operating program. Let's update our program and get this working. So we'll go to the game scene, and we have the sun. I'm just going to shift this. Sort of makes a little more sense to me. And the sun will be a light class. So we'll go back down, new sun. We'll make that light. And where are we? In the constructor for light, we need to put in the color. And we're going to declare it as a directional light. Put in the Eulers. Okay, that should be fine. Let's double check. We'll go to the renderer, and is the renderer having any errors? It'll probably have an error with color, because now color is not optional anymore. Okay, so we'll do that. Okay, give it a shot. And yes, that looks good. Okay, so now let's add a spotlight. That'll be a light object. So to create it, we'll just run through the usual routine. And I'm going to make this one red. And I'm not going to update this once, I'm going to update this in the loop. So down here we'll go. Okay, that's looking good. Then up here we have, what is it? Self is used to access sun before all stored properties are initialized. That's weird. Maybe if I just shuffle things around a little bit. There probably are better ways to do this, but the point is we just get something that works. I will admit that is quite strange, but anyway. All right, so let's get into this. So what am I thinking? We've made a spotlight, we are updating it properly. We need to read that data and put it into the shader. So I'll go to my shader over here, right down the bottom. Here we've got a directional light. Let's go constant. Of course we need to make the structs. Okay, so we'll go to definitions and we will define a directional light and a point light. Sorry, a spotlight and a point light. So we'll have spotlight here, we'll have also a position, and this will be a point light. Make that a lowercase l. And this will have a position and a color. Okay, cool. So go back here, we have, I'm going to set this in at buffer index 1. Okay, so what I'll do is grab all of this code, change the order here. So we'll start with getting the fundamental directions that we need, and then we'll go through the rest of that. Okay, now let's have a think about how we're going to set up the spotlight. So I'll just get rid of this stuff for now. So we shouldn't be seeing any lighting, it's just the spotlight. Okay, so the fragment to the camera will be, well, that doesn't have to change, does it? Because the frag position will always be the same, camera position will always be the same. That's set above. But what we do need is we need the fragment to the light. So we'll go float 3 fragment to the light equals spotlight position minus the okay, and then the halfway vector will be the sum of the fragment to the light and the fragment to the camera. So the sum of those two directions. Okay, good. Okay, so the lighting amount will be the dot product of the normal and the fragment to the light. But then we also need to take into account the direction, because that spotlight has a forwards direction and we want things which are parallel with the forwards direction to keep their length. Keep their brightness, sorry. And then we want the field away from the forwards direction to be darkened. So we're going to also take the dot product of, let's see, fragment to the light dotted with the forwards direction. And if we reverse this, we go light to the fragment. We want that to be parallel with the forwards direction. So we do that. And then this will be a number between 0 and 1. To make that light more concentrated, we raise that to a power. So let's go power of, I don't know, 32. Who cares? That's probably fine. And then we multiply that in there. I'm not going to worry about specular at the moment because it'll be pretty much the same calculation. Okay. So then the next question is, how do we get the light data into the shader? So we go back to the renderer and we say, okay, here we're setting the sun. Let's copy paste that code and do the same stuff. So we'll have set the forwards, the color, and the position. Okay, then we'll set fragment bytes. The name of that variable is spotlight, and we're going to get the stride of that structure, and that'll be setting it into index 1. Okay, let's give that a go. Unexpectedly found nil while unwrapping an optional value. Okay, let me check that. So declare directional. Have I not set a position? Ah, of course, what am I thinking? Declare spotlight. Happy with those Oilers. Now the position will be, I think I was going with -2 on the X, so a bit back from the cube, in line with the cube, and above the cube. So I think that would be, I think that's 2.0. Okay, give that a shot. Come on. Messed it up. Okay. That's all right. Of course, I haven't even written an update function. Okay. Just be 1 second, I'll write the update function. Or, even better, I'll copy paste it. Okay, so the rotation is happening around the y-axis. That's the horizontal up-down rotation. And yeah, we'll just go through the same sort of calculations. Let's give that a go. So there we see it going. Looks a little strange. Let me change that. Okay, and then in the bit here, we should be setting that with the spotlight color. Okay. Now that's looking better, but the projection doesn't quite look right. I mean, if I look at this, I'm declaring my camera so that it is on the positive y-axis. However, it looks like we're looking from the negative y-axis. So we can always just jump in here to my function. Where are we? Create look at and say, okay, let's just reverse everything with the right vector. And that's looking better. And also I can still drag around and it more or less works as expected. Okay, awesome. Okay, we almost have our system ready to go with all the lighting. Just need to do point lights and then look at multiple lights. So we'll just go back to the light, and again, I'm going to be lazy and copy paste the point light update function. So more or less what we'll do is change our position. And our position will be the rotation center plus some radius times a rotation. Yeah, that's it pretty much. Okay, so now we can sort of close this. This file's done. And we'll go back to the definitions. Oh, yep, we've got the point light there. That's looking good. Okay, then we'll go to the game scene. and we'll set this up. I'll just copy this in. Okay. So we're going to have 2 point lights. Oh, okay. Maybe we're not done with that file. Yes. Well, no. We have declared point light. So why is that complaining? Oh, should be lowercase. Okay, there we go. This is fun. I'm having fun. Okay, so we have 2 point lights. One of them is a sort of teal color. The other one is just a pure blue color. And they are both rotating around the origin, just shifted 1 unit up. In other words, the cube's sort of center of mass. Okay. Great, that's looking good. So then we will update everything. So we'll go for... Okay, great. And then we need to actually use this. So we'll go back to the definitions. And I'm going to make a struct which will just hold everything that we're going to throw to the fragment shader. So go struct, and what I'm going to have is I'm going to have an unsigned integer light count to track the number of lights that I'm using. And then when I go to my shader, I'm going to have 2 more things. I'm going to have I'm going to have a pointer, which is really an array of point light structures, and this uniform buffer object, which declares potentially a bunch of other things like scene data, like fog parameters or something. Great, and yeah, then we're going to use that. So just go ahead and grab. Oh, by the way, I forgot about this. It's the same calculation, so we can just take this factor and stick it on the end. Doesn't matter, it works the same way. There we go. Okay, so where was I? We'll grab all of this stuff. Now we'll have access light index I out of that array. Set this up. Yeah, input normal, that's fine. Frag light, that is fine. We can get rid of... Oh yeah, that's point lights. Okay, and I just realized this should be spotlight color. Okay, so then what it comes down to essentially is just setting the sort of appropriate data in the renderer. So again, we have, oh yeah, this should be buffer 3. So we'll set buffer index 2 with the array of all the point light structs. We'll set buffer 3 with the data indicating the number of point lights, and then that should work. So we'll go to the renderer. Okay, great. So we build that data and then send it over. So we go render encoder, set fragment bytes, then we go send that over to index 2, and then we'll have to set up the fragment data. Index 3. And then one more thing I forgot is this point light stride is a number of bytes per point light. We need to multiply this by the actual number of point lights. So we go and there we have it. Okay, let's give that a shot. Yeah, I mean, there it is. We've got some lights spinning around. Okay, let's enable everything else to produce the full scene. So if we go back and we enable the spotlight, then yep, we've got the spotlight working there. And then we can enable the sun. And yeah, now we've got the point lights, the spotlight, and the sun. It's a little ugly, a little hard to see when we get everything working together, but it is there. And then anyway, the point is to look at data and things anyway. So yeah, that's it. Hope you enjoyed that, and I will see you again soon. Bye.